Hi, Chelsea. Okay, so I'm here to help you a little bit with some of your math that you had going on. I kind of set up everything that I saw was in your virtual learning. But right now, I just kind of wanted to go over one area of it because it kind of all goes together with some of the word problems that your mom had sent me. Um, so, what we're going to talk about is we're going to talk about area and perimeter. Okay, so I know that usually your objectives are displayed for you, so I was just showing you Unit 5. It is within geometry and measurement, and to solve these problems, you should be able to describe and identify the properties of quadrilaterals, and then the student will solve practical problems involving area and perimeter. So I noticed that your word problems were involving squares, rectangles maybe, and triangles. So I figured we'd go over those real quick before we got into those problems. So right here, we have got a picture of a square and we've got a picture of a rectangle. Get rid of that there. Got a picture of a square, got a picture of a rectangle. And here I've got our formulas listed. And I know always when we're looking at any sort of math formula, it just looks like crazy business just because of the way that it's worded sometimes. But the technical formula for the perimeter of a square is 4 times S. S meaning the length of the side. Okay? And then the area of a square is the length of the side, squared. So S squared. And then for our rectangle here, there's different ways you can word it, but on your formula listing, I believe it should be listed as, for rectangle, that perimeter equals 2 times the side of the length, so 2 times the length, plus 2 times width, so the size of the width here of your rectangle. So length times width, 2 times length plus 2 times width. That's your perimeter. And then your area is going to be length times width. Okay, so perimeter, as you know, means you are finding the area outside of your shape. So how long is it outside all the way around of your shape on your square or your rectangle? Then your area, what you're finding is all of the shaded space inside of your shape. Okay? And the reason that there is such a big difference between the square and the rectangle and their formulas and the way they're written, we'll get into that in 1 second. I just wanted to show you as well that I took the formulas and also put them in a different form just to see it. When you have your original formulas, sometimes it looks a little weird when you see that perimeter equals 4S. All it's meaning is you're adding all the sides together. Side 1 plus side 2 plus side 3 plus side 4. With your rectangle, perimeter, same thing. Side 1 plus side 2 plus side 3 plus side 4. Now your area is technically kind of the same. It's side 1 times side 2. But they're listed differently on a square and a rectangle. The reason being that a square has different properties than a rectangle. So if you look at a square, right? Ooh, I moved him. Get back there. So if you look at a square right here, the way you know that it's a square are that all of the angles of the square are 90 degrees. Do notice that about a rectangle as well. All the angles of a rectangle are 90 degrees. Okay, so they have that in common. But on your square, all sides of a square are equal. That's important. And parallel to each other. But on a rectangle, it says opposite sides of a rectangle are equal and parallel to each other. So on your square, every single side is going to be equal. But on your rectangle, the opposite sides are going to be equal. And parallel meaning that they will run, this one's running this way, this one's running this way, and they will never cross. Then here, The last difference between the square and the rectangle is that, so when it's saying diagonals bisect, it means if you take a line and you draw it from corner to corner in a square, that when they cross each other in a square, they're going to cross each other perpendicularly, meaning that it's going to make another perfect square in the middle. Every single angle is going to equal that 90 degrees there. It's going to be all equal. And then with a rectangle, if you went from this corner to this corner, drew a line from this corner to this corner, all it says is that they bisect each other. Okay, that bisect word meaning they just cross through each other. That's why on this one I just drew a circle showing you that, look, they just crossed each other. But it's not necessarily a perfect, perpendicular crossing here with 90 degrees and it's all equal and 100%, the same. Right here, they just cross each other. So those are the differences between your square and your rectangle. And that's why your formulas look like that. So when you look at the formula sheet for your class, or if you're doing virtual learning or taking an SOL, and it gives you the formula for area of a square, that it says s squared, and the area of a rectangle says length times width. It says that because a square has the all equal sides, so you could technically take that side, one of the sides, the length of it, say it was 4, and then just square it. 4 times 4. But on a rectangle, you can't do that because this side is going to be longer than that side. If that makes sense, to show you the differences in those formulas and why they look the way that they do. They are kind of the same thing when I show you it broken down. It's side 1 times side 2, and then perimeter adding all the sides together. But when you look at the actual given formulas, that's why they look different and why they look the way that they do. And then when we move into triangles, we've got lots of different ways that they can present a triangle to you. Sometimes they might look like this. Sometimes they might look like this and have that 90-degree symbol in there where they're a right triangle because it ends in that corner right there at 90 degrees. They might have a triangle. This one, even though it kind of looks the same, this one and this one, if you notice, this one has that dotted line that's drawn in the middle of it that shows you where the height is, whereas this one tells you your height on the outside of your triangle. As long as you see that it goes from the bottom of your triangle to the top, you know that that's your height, whether it's right here or it's going through the middle of your triangle. Sometimes you might have one that looks like this. That's often one, picture you might look at that is talking about perimeter. And then all it's missing here, if they were going to try and get you to do the area, would be that line running down the middle to indicate to you what the height is. Let's see if I can get in there. It's a little crooked, but that would tell you your height. Okay. But for a triangle, you have 2 formulas. You have your area formula, which is right here. Area of a triangle equals 1/2 times the base times the height. And then your perimeter, I put my little secret there because it's the same thing as everything. Perimeter is adding all the sides together. So the perimeter of formula for a triangle, they're going to list it to you as A plus B plus C. Like this triangle here that's labeled. Add all your sides together. That's what it's telling you. Perimeter is just finding out what is the outside length of your shape. Okay? And area, yet again, is the inside portion of your shape. All that shaded stuff, what's on the inside. Okay? All right, so now we're going to move into area of a triangle. All right, and I've got a couple of examples here. So let's look at this triangle here first. I want to tell you that whenever I'm doing any sort of math problem, especially one that requires a formula, I'm going to write that formula out. Doesn't matter if you have it memorized. I want you to write out that formula. Don't try to fill things in like right at the very beginning and try to get it all in there at once. because you might end up missing something. Or perhaps maybe you might end up catching yourself and realizing, you know, oh, wait, hold on a second. Let me slow down because this actually goes here. So it's a good idea to just write out that formula first. So that's what I've done here. So we're trying to find the area of this triangle. So here's my formula. So the first thing that I'm going to do is I will write out the formula, and then I'm going to write the formula again, but I'm only going to fill in the first part that I know. So I filled in my B. I found my B, my base right here of 3, and plugged it in my formula. But if you notice, I left my H. I know it seems silly and repetitive, but number 1, it'll help you memorize your formula, and number 2, it'll ensure that you don't miss anything. So then we'll write it again, okay? And then I'll fill in the next thing I know, which is that H. Okay, I'm looking for it. I found it. Here's my height of 3 centimeters. I filled it in. So then from there you can solve. So, I mean, you can, when you write it down, you know, you'll usually write down, you know, that actual 1/2, but we know that 1/2 equals 0.5. So when you use your calculator, you can go ahead and say 0.5 if you'd like, just to make it easier when you plug it in. So let's see, 0.5 times 3 times 3 equals 4.5. All right. Oopsies. Nope, go back. So my area of this triangle equals 4.5. However, and I know you know, I'm not done, because I need to look and see first off if they gave me a unit of measurement, which they did in this triangle. They told me that it was in centimeters. So I need to make sure that I include that centimeters there. Okay? And the next most important thing is when you're finding area, because you're finding all of that, you know, area inside of this portion here, you always have to have in your answer that squared, your cute tiny little 2 at the very end, or your answer will be wrong. Okay, so I saw on some of the pictures that your virtual learning already offers that ending part for you, and all you're doing is plugging in the number, which is awesome. However, sometimes it might make you actually have to type that in as well. Or if you're doing a worksheet for your teacher at school, then you're actually, you know, might have to write down everything. They don't give you anything for your answer. So you actually have to write the whole thing. And if you just left it as 4.5, it would be wrong. Computer would count it wrong. Your teacher would count it wrong, because you must include that centimeters squared. But just so you know, if they don't offer you any sort of unit of measurement, say they don't tell you if it's centimeters, they don't tell you if it's miles, they don't tell you if it's anything, and they just have numbers. Do I have one like that? Let's see. I got a whole bunch with letters. If they just give you numbers, then your unit of measurement is literally just going to be the word unit. So you could say units squared, but you must include that unit of measurement. So now on this example over here, I just wanted to point out to you, I know I already filled this one in here, sort of, because it's a picture I clipped and it's not done the way that I like. So you know what? Let me pull that text box down. Now I'm going to get me another text box because I don't like that. That's trying to go way too fast. So what I'm going to do is I am going to steal that H. Come here. I'm going to steal this H over here. Copy. All right, and I am going to get me a text box. And I'm going to cover up this 10 here because I don't like to go too fast. I know. You're like, this is just silly. But it really will make a difference for you. Okay, so I'm covering that up. And then I'm going to put that H over there. Just like that. So now I can carry this down and I can go ahead and fill in what I have for H. And what I wanted to show you on this, the most important thing other than, you know, changing all that triangle up, was that sometimes they will try and trick you or try and catch you up with the way that they present that problem to you. And they will show your triangle like this, and it looks way different than that other triangle did. and we're going to fill in our H. All right. No, yep, get on right on out of there. And fill. We're going to fill you up on there. Text box with white. Okay, so what was our H? All right, so this one I want to show you. Here's our triangle. Looks way different than this one, right? I mean, that one's clearly defined. It's right here. It shows you from bottom to top. Here's your height. Over here, they show you your base. And then it comes out a little bit with this dotted line here. And then it shows you that 90-degree symbol. And then it shows you this straight up here. Your height is right here. Bottom to top. This 10 centimeters. Okay? So let me plug in. Can I write in that text box? Oh, I can, yay. All right, I'm going to plug in that 10. Okay, I'm going to make that blue so it matches the H that's up there. Let's make that nice and the same. Okay. Every time I add a new one, look, it just keeps on. I got to keep on making it bigger. All right, so there is your height, okay? And they're going to try and trip you up and add this, 3 centimeters out here, letting you know that it came out here, this 3 centimeters, and this, and here we're going straight up because this triangle doesn't, go perfectly straight up in the air, or it doesn't stand at 90 degrees. This means nothing to you right now. Okay, it may later on in a different type of problem or a different type of scenario, but it's almost like a trick. It's extra information that you don't need right now because your area is just this 1/2 times your base times your height. Your base of this triangle is only 12. This extension here, you're not going to add that 3 in there. It won't be 15, 12 plus 3. It's just 12. So 1/2 times 12 times 10, so 1/2 times base times height is 60 centimeters squared. And let's just make sure. We're going to do 1/2, so 0.5, times base 12 times height 10 equals, we're good to go, 60 centimeters squared. And I did not forget my squared because I want to be correct. And I don't want my teacher to count it wrong. And then I just popped it on up here again to remember. There's no reason to really go over it because perimeter is just adding all your sides together. A plus B plus C. I popped it up here again just to remind you. But as simple as that sounds, they're going to try and get you. And sometimes they might have tricky perimeter problems. So they might give you this triangle here. And it's got all kinds of crazy business in there. I mean, there's C's in there and I don't even know what. And so you have to try and find the perimeter of the triangle below. Now, if they don't give you anything for C, if they didn't say, sometimes a problem might say something like this. Find the perimeter of the triangle below. Oh, let me undo what I was trying to do there. Delete. Get out of here. I don't want you. Go away. Find the perimeter of the triangle below when C equals 6. Okay. Maybe they'll make it look like that, when C equals 6. Okay. And then you'd have to plug 6 in every time you see C. But sometimes they still might not do that. And it'll just say, find the perimeter of the triangle below. And it'll give you these strange little looking equations here and not tell you what C equals. So what you have to do is add all your sides together. So you're going to figure it out. Now this one, your triangle is labeled at the corners. It's kind of weird, right? So all it's meaning is, this side is like A to C and then C to B, B to A, or A, B, C. It doesn't matter because you're just adding them all together. So you can pick, okay, here's A. 6C plus 4. Now I'm going to find B. B. 8C plus 1. Now I'm going to find C. 10C plus 4. There we go. So we plugged it all in. Now what we're going to do is you're going to have to combine your like terms. Okay? Meaning you're going to start adding all together all the things that are the same in the same form. So anything that has a C with it would be added together. And anything that is a number that's standing alone all by itself will be added together. So if we did that, let's pull them down. Okay. Let's have two columns here. Let's pull down all the ones that have a C. So 6C, all right, we did that one, plus 8C okay, oh, and there's another one, plus 10C, oops, no, 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 you better get in that one, you are a C, get in there with those C's, plus 10C, okay. Now all these ones that are left over, and you know what, I'm going to make this yellow, so because we know that all the C's were yellow. Now all these standalone numbers we're going to add together. So this 4, okay, 4 plus 1 plus 4, okay. Let's make those pink so we know that those all went together. Okay, that's what combining your like terms means. You would find all the ones that are the same, like the same format or however you want to word it, and put them together. So all my C's went together, and then all those lonely little numbers went together. Then you can add them up. Now when you're adding those up, I'm going to add my lone numbers first because that's really easy. I mean, it's just adding numbers together. 4 plus 1 plus 4, 9. All right, so I'm going to change this to 9. Okay. Now this one, you're going to add a little bit differently, but pretty much the same. You just have to remember to keep that C, because C is not a number, is it? You can't add that together. You're not multiplying it, so there's nothing else to do with it. You would just leave it there, and all you're going to be adding is these numbers that are in front of that C. So 6 plus 8 plus 10. 6 plus 8 plus 10 is 24. And the way you'll show it is you would say 24C. Okay? So your answer is done. Can I do anything else? I can't do anything else with this because I cannot add 24C plus 9. They're not the same. 24C is not the same as a nice little lonely 9 by itself. So my perimeter equals literally the equation 24C plus 9. That would be the actual answer right here, Chelsea. I mean, there's nothing else we can do with it. And it seems a little funny because we, you know, have this thing sitting there that looks unfinished, but you can't add things together that are not supposed to be added together, right? So, the perimeter of this tricky triangle below is 24C plus 9. And let's make that stand out with red. So those, I think, are the most ridiculous ways that they can try and trick you or trip you up with examples of things in area and perimeter. Okay, and then we can get into talking about these word problems in just a little bit. But I just wanted to show you why these formulas are the way that they are. And I wanted to show you how they can try and take those formulas and make it look different to you, either by the picture or by the way that they word it or by leaving things out and making you have to have an answer that looks unfinished. So all those different things are the ways that these problems slowly start to get more difficult for you. Okay, so what I'm going to do is I'm going to go ahead and stop this, and we're just going to leave this as a tutorial just about an introduction of area and perimeter, and then we can talk about those word problems a little bit later, because what I'm going to do is the word problems that were sent to me, I did the actual word problem from your homework, and I'm not sure if you're able to go back and fix them or not, but I'm just going to change the numbers so that way you get the concept, but then we're not just, you know, throwing my answer on onto your virtual learning. Okay, so I will see you in just a little while, and I will get those up there to talk about these word problems.